Hey guys, my name is Harini and today we're going to be talking about exponent rules. So, the first rule that we're going to learn today is called the product rule. And basically, when you have something like a to the power of m times a to the power of n, what you're going to want to do is add the exponents up. But we should keep something in mind first. All these rules that we're going to talk about today only apply when the bases, which are the a's right here, are the same, okay? So these rules only apply when the bases are the same. So since we have the same bases here, we're going to carry out the product rule. So we have a to the power of m plus n, because in the product rule, we're going to add our exponents, okay? So let's get on with the examples. For the first one, we have x to the power of 3 times x to the power of 6. Okay, first we want to make sure are our bases the same. We have an x here, we have an x here. Yes, they're the same, so we can do the product rule. So we're going to add up our exponents. So x to the power of 3 plus 6, that gives us x to the power of 9, and that is our answer, okay? Our second example is 3 to the power of 3 times 3 to the power of 2. First, we check if our bases are the same, and 3 are the same, so we can do the product rule. So what we're going to do is 3 to the power of 3 plus 2, and that's 3 to the power of 5. And for those of you that don't know this out of the top of your head, 3 to the power of 5 is 243. Sometimes they'll ask you just the simplest form, like, so this is either right or this is either right. Like, it typically depends on what your teacher tells you to do, okay? Our next rule is the quotient rule, okay? So that's going to be a to the power of m divided by a to the power of n, okay? And this also follows by the rule that your bases have to be the same. So what we're going to do is, for quotient rule, we subtract the exponents. So this would be a to the power of m minus n, okay? So for quotient rule, we subtract, and product rule, we add, okay? So our first example is 6 to the power of 3 divided by 6 to the power of 2. Our bases are the same, so we can do the quotient rule. So we're going to write down our base, 6 to the power of 3 minus 2. And that is 6 to the power of 1, and that simplifies to 6. And that's right, okay? So our second example is written out like this, okay? This is basically the same thing as this. This is basically saying x to the power of 5 divided by x to the power of 2, okay? So what we're going to do is write down our base and then do 5 minus 2, because same thing as this. It's just written out differently, okay? But they both mean the same thing, okay? So deep breath. So x to the power of 5 minus 2, okay? Because we're subtracting our exponents, gives us x to the power of 3. And that's our answer. Pretty easy, right? Our next one is exponent with 0. Oh my god, what are we going to do? What does 0 mean? Oh no. Well, guys, this is the easiest out of them all, okay? So if you have anything to the power of 0, a to the power of 0, anything to the power of 0, that's going to simply equal 1, okay? So x to the power of 0, 1. 100 to the power of 0, 1. Anything to the power of 0 is 1, okay? Easiest rule out of them all. That's the best thing out there, okay? So that was easy, right? Oof. The next one, negative exponents, okay? This is pretty tricky, but it's easy to learn. So if you have something like a to the power of negative m, what you want to do is something to like a reciprocal approach, okay? So what you're going to do, if this is this thing, this is the same thing as over 1, okay? So what you're going to do is switch it and then just take the exponent out. So this is basically 1 over a to the power of m. Okay, so you're going to have the reciprocal and just take the negative out of the exponent. So this x to the power of negative 9 is going to be 1 over x to the power of 9, not negative, just 9. And 3 to the power of negative x is going to be 1 over 3 to the power of x, okay? If you have something like 1 over x to the power of negative 9, okay? If you have something like that, well, the reciprocal of this is just going to be x to the power of negative 9 on top, and then just take out the negative. So the answer to that is simple. It's x to the power of negative 9. Okay, easy? Yeah. Okay, our next one is exponent with fraction. So whenever you have a fraction in your exponent, all you want to think about is a square root. Okay, so what you're going to do, draw your little square root symbol. Okay, write your base inside the square root. Okay, now what you're going to do is put the top of the fraction inside the square root as the exponent of the base. So you're going to do m here, and the bottom of the fraction out here as the square roots thing. Okay, so this would be x to the square root. Just put the square root symbol, and then you're going to write your base in, and then you're going to write the top here, and then the bottom out here. So top would be inside, bottom outside, and this is your answer, okay? For this, you write your square root symbol, put the 7 inside the square root, okay? And then put the top of your fraction with the 7 as its exponent inside the square root symbol, and then the bottom outside the square root symbol, okay? And if we can go ahead and simplify this, but it's just too much, but we can if we want. So the fifth root of, I don't know if that's how we're supposed to say it. Fifth root of 7 to the power of 3. Let's simplify 7 to the power of 3. That's 343. Okay. And if we fifth root that, I'm getting some decimal, and we get 3.2141. Okay. We don't have to do all this work. We can just basically stop here. But yeah, for all of those people who are extra, here's your answer. Okay. Okay, our last two final rules are, look, you have something like this. You have a parentheses, and then you have a and b here, and then you have exponent there. What you're going to want to do is just rewrite this thing with the exponents. So what it's going to look like this. A to the power of m times b to the power of m. Okay? So you're just going to give that exponent to each of the variables inside here. So this is basically x to the power of 6 times y to the power of 6. Just give the exponent, distribute that into the parentheses, okay? And you're going to get this. This is when you have a fraction kind of thing. Basically, you're doing the same thing you're doing here. Just give that exponent to the variables inside the parentheses. So you're going to have a to the power of m over b to the power of m. Whoops, that just went a little weird. Okay, b to the power of m. So our example, x over y to the power of 4. We're going to do x to the power of 4 over y to the power of 4. Okay? Okay, before we end the day, we're going to look at one more thing. Remember how I said these rules only apply if the bases are the same? And, well, what do you do when the bases aren't the same? Well, if you have something like x to the power of 2 times y to the power of 4, what do? Do you do x to the power x times y to the power x times y to the power of 2 plus 4? Does that give you xy 6? Is that what we're supposed to do? Nope. Nuh-uh. No. That's not what you're supposed to do, okay? If your bases aren't the same, what you want to do is leave them as it is. Simple. If your bases aren't the same, leave it as it is. No need to do all this stuff here. Just leave it as it is. Okay guys, sadly, that's the end of our video today. But thank you for watching, and I really hope that this was very informative and will help you guys in the future. Thank you so much, and I hope you guys have a great day. Oh, one more thing. Since you guys are all great viewers today, you guys totally deserve one of my famous big smiley faces. Thank you so much for watching, and I hope you guys have a great day. Bye!